Okay, in this video, I will be going over the immune system as covered in Bio 104 Human Biology class. So, if you can take a moment to draw what I have up here right now, this is a representation of a blood vessel with one lymph node down here. So, with this drawing, I'm going to be going over several different kinds of white blood cells that you'll see, and how each one has their own unique function that comes together to work as a whole immune system against different kind of pathogens. So I'm going to make this kind of like a little bit of a story to tell you how the immune system works. And so a few things I'm going to draw on here now is that just to remind you that you do have red blood cells that's going to be circulating around through the blood. These are called erythrocytes. That means red cells, and their main function is that they carry oxygen. I'm going to put down that these are oxygen carriers. Okay, so next I'm going to draw some pathogens showing up. So here's pathogens. Now, the definition of a pathogen is that it's a foreign invader. It could be a bacteria, it could be viruses, it could be a fungus. It's something that does not belong in the body. Right? And so that is now within the blood, and it's going to trigger your immune system. The first responders in your immune system are the neutrophils. And the neutrophils, they're small, but they're absolutely numerous. So they're going to show up here, and so I'm going to draw them on here like a little, like a bean shaped type of a deal here. So I'm going to draw quite a bit of them to show that they're the most numerous of the white blood cells. Okay, so here we got the neutrophils, and we're going to call these the first responders. So they're going to come in, they're going to try to neutralize the pathogens a little bit. Okay, and so they're going to slow down the spread of that pathogen throughout the body, but they can't do it alone. So they're going to have some helpers along the way here. One of those helpers would be the eosinophils. So I'm going to put them as red because they usually have a little bit of a reddish purple tint to their cells. Now, the eosinophils, they're not as numerous as the neutrophils, so that's why I'm only going to put two of them on there. But their specialty is killing off parasites. So yeah, they'll help out with any type of pathogen, but if someone has a parasitic infection, they're going to have a very high, unusual level of eosinophils. So eosinophils, I'm going to put down parasite killers. Alright, and then the next ones I'm going to put on here, I'm going to put as blue. Again, they're not as numerous as the neutrophils, but they're going to come out here. These are called basophils. Now the thing about basophils is that basophils, they are vasodilators, which means they dilate blood vessels. They open up the blood vessels so more blood, more white blood cells can come in to fight off the pathogens. And so how do they do that? They release histamine. Histamine. Now you may have heard of histamine, or at least antihistamine. Histamine is a chemical that's released when someone has let's say, an allergic reaction. And so you can blame basophils for your seasonal allergies. If you have redness, itchiness, things like that, that's all due to histamine that's released by those guys. And so I'm going to put down that these guys are vasodilators. They love to dilate blood vessels with histamine. So when you're taking an antihistamine, you're pretty much telling those guys to chill. Okay, don't get all bent out of shape because of this harmless thing, whether it's pollen or pet dander or anything like that could trigger allergic reaction, but it's completely harmless to the body. Alright, so these three is what I call the granulocytes. So I'm going to put that word up here, granulocytes. That just means cells with granules. So they'll look like a granulated egg, like a speckled egg a little bit. Let me tilt them. So you have like spots on the cell. So these three right here, I call them the fills. Okay, so granulocytes are fills. So neutrophils, eosinophils, basophils, they all have those little granules, little spots all over their cells there. So those three are going to be pointing out the pathogens. They may take down the numbers somewhat here, so we're going to take down the numbers here, but they still are sticking around though, longer than they should. So now it's time to bring in the brains of the operation. And so I'm going to draw two important type of cells here. One's going to be here, and one's going to be in here. So notice I have one that is out and about, and I have another one here that's just lounging around in a lymph node. Let's talk about this one right here. This one is called the T lymphocyte. T lymphocyte. Sometimes we just call them T cells. Okay? What I want you to remember about T lymphocytes or T cells is that these are the generals. They are the leaders here. They are the ones that organize all this, and they can be involved in specific type of attacks. They can even go up and they can make a pathogen just rupture, a bacteria rupture. They are quite deadly. They use a whole variety of different ways to combat these pathogens. And so they are the generals. Now, while they're observing this whole battle, the T lymphocytes are in constant communication with their buddies down here, the B lymphocytes. Or the B cells. These guys, I want you to remember them as memory cells. They are the ones that have to remember if we have faced a pathogen before or not. And so while all this battle is going on here, the T lymphocytes will be in communication with the B lymphocyte. If we hear this conversation, it probably will sound something like this. Hey B, how's it going? Hey, what's up T? What's going on? Well, listen B, we have a situation going on here where we have these pathogens out and about here, and the question I have for you B is that have we faced these guys before? If anyone will remember, you will. B cell will take a look at it and go, I don't know. Those pathogens don't look like they sound familiar at all. I do not think we have faced these guys before. But give me a few days and I will make antibodies for it. Or a weakness. Something that will bind those pathogens together so we can defeat them once and for all. And so when the B cells are activated to make these antibodies, the lymph nodes are going to swell up. And that's why if you go to the doctor and you're not feeling good, the doctor will feel your lymph nodes and go, oh yeah, they're a little bit swollen. Swollen lymph nodes means that these B cells are active. They're active because they're fighting something. They're trying to find antibodies. They're trying to create antibodies to help you out in fighting something. So it's a really good indicator that there's an illness going on if your lymph nodes are swollen. And so now it's just a matter of time for the B lymphocytes to develop these chemicals called antibodies. And when they do finally create these antibodies, and they're shaped like a Y, so I'm going to make them like this. So these are the antibodies. I want you to think of antibodies kind of like handcuffs. Okay, they're really going to immobilize the pathogen. So once a B lymphocyte releases those antibodies are going to bind to these pathogens here, like this, and really strictly immobilize them. So why is it important to immobilize them? Because that's when our last white blood cell is going to come in. And this blood cell is the largest one of them all. This is called the monocyte. sometimes called the macrophage, which means big eater. That's exactly what it is. It's big and it likes to eat things. So as soon as you immobilize those pathogens, this big macrophage is going to come in and gulp up those pathogens and be done with that. So now what's going on here is this B lymphocyte is going to remember exactly what the pathogen was and what was the antibodies used against it. So if the pathogen shows up again, right away the T lymphocyte will say, hey B, have we seen this before? Yes, definitely we have. Here's an antibody for it. It gets destroyed really quickly. You don't even get sick. Now that is the reason why vaccinations work. Vaccinations is introducing a weak or dead virus to an individual and gives an individual time to develop antibodies against that weakened or dead virus. So if we come in contact with the real deal, we already have the antibodies for it, so we don't get sick, or we get mildly sick, very mild symptoms, not severe symptoms, and it's not as long lasting of an illness either, because we prepared our immune system ahead of time. Now, some viruses go through mutations. When viruses mutate, our antibodies will not work as well anymore. So sometimes what viruses do is that when they mutate, like the flu virus, we have to get a vaccination every year, because if that flu shows up again, but this time it's a little bit different, let's say this time it has a mustache on there, the B lymphocyte will not recognize it, so it won't think that those antibodies are going to work, so it's going to go through a whole idea or the whole spiel of making more antibodies to fight off this one, which will take 5 to 7 days, and you're going to be sick for that long. But if you got a vaccination that year, it could give our immune system a heads up and say, hey, psst, this flu virus is going to look a little different this year, but it's going to look like this. Okay? And when you get the vaccination, you're going to be given a dead virus with that mustache on it, let's say, and it tells the immune system, this is what the real deal looks like this year, prepare yourself ahead of time for it, and we're not going to get get ill for long lengths of time, or symptoms will stay very mild. So that's a good overall spiel of how our immune system works. I know it sounds very complicated, but hopefully this helps break down the notes for you a little bit. So if you have any questions, make sure you email me or post the questions on the forum, and I will respond to it as soon as possible.